This is the solution for the study guide for chapter, or for the quiz number 25, sections 3 and 4 and 5 from chapter 10, and section 5 from chapter 5. So let's take a look at our first problem here. And what it's asking us to do is to simplify this expression. So all we're going to do is take out the perfect square in 8. And so I see that the perfect square is 4. So 4 times 2 makes 8. And then over here I bring down the minus 2. And I take out the perfect square in 50. So 25 times by 2 makes 50. And so when I take the perfect square out, I'm left with 2. And I still have the radical sign and the 2 underneath it. Bring down the minus 2, and the square root of 25 is 5. And the square root of 2, well, I can't take that, so I just leave it underneath the radical sign. Notice that common mistake is people like to keep the radical sign around the number after they have taken the square root. Don't do that. You've taken the square root, there's no more radical sign. So now we go ahead and multiply. The 6 and the 2 make 12 square roots of 2, minus 10 square roots of 2. And together that makes 2 square roots of 2. So the next problem, we're going to end up rationalizing the denominator. On this next problem, we're going to end up multiplying by the conjugate. And so the conjugate is the same number, same terms, but just opposite sign in between the two terms. So here we are subtracting, taking a difference. So the conjugate is going to end up being the sum. And so when we go ahead and do that, 12 times by the square root of 11 plus the square root of 7. Now notice I'm keeping the 12 on the outside. I'm doing that because when I go ahead and multiply the sum and the difference, we're going to cancel out the outside and inside terms. And so again, I'll show you down here what this looks like. The square root of 11 minus the square root of 7 multiplied by the square root of 11 plus the square root of 7. So the first terms end up giving me 11. Square root of 11 times the square root of 11. The outside terms and the inside terms, notice that they're the same terms, but just opposite in sign. So 11 times 7 makes 77, but here I have a negative times a positive, so I get a negative square root of 77, and those cancel out. The last terms make a negative 7. See, 7 times 7 makes 49. The square root of that makes 7. So 11 minus 7, that's where I'm getting 4 from. So notice that I left those two terms, and get the 4 again from the 11 minus 7. Notice that I left this 12 outside so that I can see the reducing that will end up going on here. So I take out the common factor of 3, and that leaves me with 3 times by the square root of 11 plus the square root of 7. And so you can go ahead and write that as, instead of factors, you can write it as a sum here. So the square root of 11, or 3 square roots of 11 plus 3 square roots of 7. So in this next one, we're trying to find the missing side of the right triangle. It's the hypotenuse. And so I'm taking the square root of 7 plus the square root of 2, and I'm squaring that term. And then I'm adding on the square root of 7 minus the square root of 2. And I'm squaring that term. That's going to equal x squared. And so when I square this, I end up getting 7 plus 2 square roots of 14, and then plus 4, plus the square root of 4, which is 2. And so from this point, I got this 2 square roots of 14 again by, if you look at the square root of 7 plus the square root of 2, and I write another one out, square root of 7 plus the square root of 2, you see how they're the same terms. You have one of them here, square root of 7 and the square root of 2 make the square root of 14, but you have another one right here, and that's why I have 2 square roots of 14. So this next one, it's the same sort of thing. You have 7, and in this case, instead of the plus sign, we're going to have negative signs here, and that's going to make negative 2 square roots of 14. And the last term is going to be a negative times a negative makes a positive square root of 4, which just makes positive 2. And this all equals x squared. So when I combine, the square roots of 14 are going to cancel. The 7 and the 2 make 9, and another 7 and 2 make another 9. So 9 plus 9 equals 18, which equals the square root of x squared. So I'm going to take the square root of both sides to cancel out the squared symbol. So x is going to be 3 square roots of 2. I get that by taking out the perfect square of 9 and taking that square root. And so these are, don't know what the units are, so I'll just put in units. So taking a look at the next problem, here I'm asked to solve the radical. And so the way we do that is we isolate the radical. Well, they're already isolated. So then I just square both sides, and that'll cancel out the radical sign. So I'm left with 4d plus 3 equals 7d minus 3. So I'll go ahead and do some opposite operations to isolate the variable. So I'll subtract the 4d's from all sides. We add the 3 to each side, so I'm left with 6 equals 3d. So when I divide by 3, I get 2 equals d. So I want to check the solution, make sure it works. So I put 2 back in for d there. I get 8 plus 3 makes the square root of 11. And then on this side, I get 7 times 2 makes 14 minus 3, which is also an 11. So when the numbers are equal, then yes, it checks out. So this is the solution. On this one, though, we have to square both sides, and we're left with a quadratic this time. See, x squared equals 2x plus 8. So I need to move the 2x, move the 8 over, so you're subtracting them from both sides. And so from this point, we can go ahead and rewrite it as x squared minus 2x minus 8 equals 0. So when I factor, it factors down to an x minus 4 and an x plus 2. This all equals 0. And so when I set the factors equal to 0 to come up with what the two solutions could end up being, I end up having to use some opposite operations, and then I end up getting my two answers. So I get 4 and negative 2. But I got to check the solution, see if they work. Well, I see right away this negative 2 is not going to work. The reason is you can't have the radical sign equaling a negative 2. And so I have 2 times by negative 2 plus 8. That does give me 4, but the square root of 4 is positive 2, not negative 2. So that tells me this is not the solution. If I plug in 4 in for x, I end up getting a 2 times 4 plus 8. That gives me 16. And the square root of 16 is 4, so that does check out. So 4 is the only solution. On this next one, this problem's a little bit tough to do without the calculator. You're not going to have the calculator on the test, so it does say round in the nearest hundredth. On your problem, you won't have pi, you won't have a number that's very difficult to make it, so you'd have to use a calculator. So, and the reason is that the first 3 problems you can do without the calculator and have it do all the work for you. So we need to make sure that we can do the problems ourselves. So it says that the radius r of a cylindrical can with a volume v and a height h is given by this formula. What is the height? So we're trying to solve for h of the can if the radius is 3 inches. We're going to substitute that in there. And it says the volume is 65 inches cubed, so we're going to substitute that as well. So now we've got the square root of 65 over pi h equals 3. So we're ready to go ahead and square both sides. So when I do that, I'm left with 9 equals 65 over pi h. So I'm going to go ahead and multiply by pi h to cancel out the pi and the h, but just mainly to get the h up on top of the fraction and to get the pi to the other side. So now I've got 9 pi h equals 65. So I want to get h by itself, so now I'm going to go ahead and divide by 9, pi. And this will be my answer. H equals 65 over 9 times pi. And your problem is going to be one in which you can actually come up with that answer. In this case, I'm going to use a calculator for this part. So I go ahead and write in there 65 divided by, and then I'm going to use some parentheses to make sure 9 gets multiplied by pi. And the pi symbol is right here, and I can go ahead and close those parentheses, and that gives me what 9 times pi is, but then I'll press equals, and then it'll divide it by 65, and that gives me 2.29. So I'm supposed to round to the hundredths place here, so the 8 is going to round that 9 up to a 0, which will round this to a 3. So 2.3 inches is equal to the height. Again, your problem you can do without the calculator. So on the next 2 problems, again, we don't have the calculator, so we're going to end up having to graph this function without. So we're going to use translations to graph. So when we have a positive 2, that is outside the radical sign, so it's not underneath. That tells me that it's going to translate translate 2 spaces up, 2 up. And so it's going to start right here, and then it's going to make that regular radical, graphing a radical of the square root of x. And if you're not sure, then you can just go ahead and plug in some numbers and make a table. And so the table is going to look fairly consistent each time. So if I plug in 0 for x, and that's what I get, because the reason I plug in 0 is because the square root of x is what I have underneath. There's nothing else. So I set whatever the radicand is greater than or equal to 0, and that gives me my domain. So I know my domain values should start at 0 and go up. So I plug in 0, I get 2. The reason I get 2 is because I get 0 for the square root of x, but then I got to add 2. And so when I plug in 1, I end up getting 3, because the square root of 1 is 1 plus 2 makes 3. When I plug in a 2, the square root of 2 is 1.4 plus 2 makes 3.4. And so the square root of 3 is 1.7. 1.7 plus 2 makes 3.7. And the last one I'll do is 4. The square root of 4 is 2. 2 plus 2 makes 4. So that tells me that I've got some points here, and I'll be able to sketch that graph. So the graph is going to look the same for all of these. They're just going to be in a different location, so it translates 2 up. If this were a minus 2 here, then it would translate 2 down. Now this is a little different because it's underneath the radical sign. The 1 is. Notice how that radical sign is x plus 1 is underneath it. So we're going to go ahead and take the x plus 1, set it greater than or equal to 0. I've got to subtract the 1, and that gives me x is greater than or equal to negative 1. So when I start this, I'm not going to start at 0. I'm starting at negative 1. So that's where the graph starts. The graph's going to look exactly the same. You see, if you go ahead and plug in, again, I plug in negative 1, I get 0. If I plug in 0, I get 1. And notice you're going to go over 0 and then up 1 space. So that's going to be our next point. If I plug in 1, the square root of 1, well, 1 plus 1 makes 2. The square root of 2 is 1.4. And the square root of 3, when I go ahead and plug 2 in for x, 2 plus 1 is 3. Square root of 3 is 1.7. And if I plug in a 3, that makes 4. The square root of 4 is 2. So you notice how the graph looks pretty much the same. It's the same graph, just shifted over. So the key is when a number is being added to the radicand, like a 1, that's going to end up moving it to the left. It's going to translate left 1. If I was taking away 1, then it would translate right 1. So our next problem is going to be one in which we have to graph write an equation in slope-intercept form. So the first step is to find the slope of the line. So I'm going to do 25.5 minus 8.5 and divide by 3 over 1. And so I go ahead and do that subtraction, and that gives me 17 over 2. That's going to give me 8.5. And so from there I'll take one of the points. I'll take this 1, 8.5 and substitute into the point slope formula. So it goes y minus y1 equals the slope, 8.5, times by x minus x1, which I'll plug in 1 for. So I do that distribution, and I'm left with y minus 8.5 equals 8.5x minus 8.5. Well, when I go ahead and add 8.5 to both sides, I end up canceling these out to make 0. So I'm left with y equals 8.5x. So that's the equation. And now I have to interpret the y-intercept and slope. And so the slope of the line is equal to 8.5, which represents, and this is where you have to read the graph, which represents, and then I read this and it looks like it's time worked and wages earned, which represents earning $8.50 for each hour of work. And then the next one is the y-intercept. The y-intercept is 0 in this case. So that means, which means when you don't work when you don't work, when you have no hours worked, you do not earn money. And another way to think of that is that you don't have a starting bonus. You didn't start with any extra money. You started with $0. So sometimes you might get like a sign-on bonus that somebody might pay you a few dollars just to join their workforce, and in this case you did not get that. So you didn't start with any extra money, you just start earning from when you start working, and that's what the y-intercept represents. So those are the types of problems that you're going to see on this week's quiz. Good luck.